Okay. So, Chapman integration by parts, you have to use a formula which is given on the data booklet. Okay? So, first we're going to study how we get the formula. Okay. It comes from the product rule that you introduced before. If you are differentiating UV, okay, U dV dx plus V du dx. Okay? As you're studying integration, so if I integrate this, I need to get back UV. Okay? Because integration is a reverse process. So I'm differentiating UV, I'm getting that as an outcome. So if I integrate this, I need to get back UV plus a constancy, of course. Okay. So integration of U dV dx plus integration of V du dx equals UV. Okay? So integration of U dV dx is simply UV times integration of V du dx. So that's the formula of integration by parts. Okay, so that's the formula you get on the formula sheet. Okay, exactly the same thing. Integration of U dV dx equals UV minus integration of V dV dx. Some people don't put the dx's, they just put dV. That's a big thing there. Okay? Is that fine? Don't really need to copy it because you get the formula. They won't ask you to prove the formula, for example. Okay, but in case you wanted to know where it comes from. So let's try to integrate x dx. Of course, every time you're integrating, you need to put dx. Okay, so you've got different functions here. Now, some students and some teachers use one technique, which I told you before is not approved by the Maths Council. Okay. Because of various reasons, because it doesn't work the whole time. But that can be a good guide. Okay, light, we can use that technique. Okay. The L stands for log, the I stands for inverse trig, the A stands for algebra, so algebraic terms, T stands for trig, and E stands for exponential functions. Okay, if you go to different schools, they may have different versions of an I. Maybe they've involved another term also in the I. Okay? So, our formula is integration of U dV dx equals UV minus integration of V du dx. You need to know that some people don't use light at all, they just integrate. Some people integrate, they get stuck, then they switch terms. Okay? So if you're using light, it doesn't mean that you will be able to solve. You may get stuck during exams, but most of the time it works. So maybe it works in 65% of cases, which is enough. Okay? So we use light to choose which one is going to be the U. Because we are integrating U dV dx. So I've got one term, which is, one of these terms is U, and one is dV dx. You can't just say U equal to x because it comes first, as in the formula. It's not like that. Okay? So, in the light, okay, that's an algebraic term. And that's an exponential term. So which comes first, algebra or exponential? Algebra comes first. So I'm going to choose U equal to x. So automatically, dV dx is going to be dx. Okay? Now, in my formula, I've got du dx. So I just differentiate that. Du dx is 1. In my formula, I've got v. I've got dV dx. So to get v, I just integrate dx. So if I integrate dx, it stays the same. So v is simply dx. Is that okay? So integration of u, which is x, dv dx is ex, dx equals uv. So my u is x, my v is ex, minus integration of v, which is ex, du dx, which is 1. Completed x, ex, integration of ex is simply ex. Now you can write the c. Done. That's answer. Good? You've got a few discussions on whether to use light or to use a different approach. You've got that on the forum. Okay, I've quoted another forum, which is quite good, and there is a good discussion on that, what to use when. Okay, you can read it, it's going to be good. And you've got one video also.
In the exam, do you have to simplify your answer by putting ex on top?
If you want. You can write ex, x minus 1 plus c. Next with the 3. Okay, some people choose u by thinking about that. Okay, I'm going to choose u for the function that is easier to differentiate. So if I have x and ex, x can be differentiated easily compared to ex. Okay, so I choose u is equal to x. So if you've got two functions, use always the one which is easiest to differentiate. Some people will start like that, and they're going to get the same answer anyway. Okay? So that's one example where you're applying integration by parts once. Sometimes you may be applying it twice, or in rare cases, 3 times. Okay? So we'll try to look at one where we're applying by parts 2 times. Okay, integration of x squared cos x. So if we consider light, you've got an algebraic term here. That's algebra. And that's it, trig. So which one comes first, algebra or trig? Algebra. Algebra. You've got algebra and then you've got trig. So my u is going to be x squared. And my dv by dx is going to be cos x. So my formula is integration of u dv dx equals u v minus integration of v dv dx. Okay, from the formula sheet. If you forget, you can just quote it. So du by dx equals 2x here. V equals the integration of cos x, which is sin x simply. So apply it, uv, so x squared by u, by v is sin x, times sin x minus integration of v, which is sin x, du dx, which is 2x dx. So x squared sin x minus, the 2 is a constant, you can write it before the integration sign, minus x sin x dx. So what happens here? It's not simplified yet. You still have a product of 2 functions. So we have to apply by parts again. So algebraic trig function, algebraic comes first. So what's the again, x squared sin x minus 2. So I'm going to apply by parts to that section now. Okay? So my u is x, and dv by dx is sin x. So du by dx equals 1. V is integration of sin x, which is negative plus x. So apply by parts here, so uv. So my u is x, my v is negative plus x. uv minus integration of v. du dx is 1. So times 1 here. Continue, x squared sin x minus x cos x plus minus integration of cos is simply sine. So sin x plus c, you can write the plus c now. So x squared sin x plus x cos x minus sin x plus c.
Non? Parce que le nu dans l'integration x sin x, nu c'est x. Non, parce que voilà. Isn't it 2?
Sort of x squared sine x plus 2.
There was a 2.
Yeah.
Parce que c'est une deuxième intégration. C'est le deuxième principe.